Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of second derivative. So as per the problem, determine the value of the second derivative at the value indicated. State whether the curve lies above or below the tangent at this point. So we are given the function s at t equals 2t over t minus 4, and we have to find the value of the second derivative at t equals -2. Now this function s at t is a rational function. Now since we have to find the second derivative of this function, it will be better to move this denominator to the numerator because that will make it easy to find the second derivative. So the first step is to change this given function equation. So s at t equals, so the numerator stays as it is. So we move the denominator expression t minus 4 to the numerator, and that makes the exponent of this expression -1. Now we can find the first derivative of this function and then we'll find the second derivative. Now this function is made up of two functions being multiplied. The first function is 2t and the second one is t minus 4 exponent -1. So we can use product rule to find the first derivative. So prime of s at t. So as per the product rule, we'll start with the derivative of the first function. So the derivative of 2t is just 2 times the second function and plus the first function times the derivative of the second function. Now for the second function, we'll have to use chain rule because there's an inner function t minus 4 and the outer function is the exponential function with the exponent -1. So we start with the derivative of the outer function, and for that we'll have to use power rule. So we'll move the exponent -1 to the front and subtract 1 from the exponent. Times the derivative of the inner function. So the inner function is t minus 4 and the derivative of that is 1 minus 0. We can ignore the 0. So now we can simplify this expression. So the first part stays the same. Now in the second part, so 2t times -1 is -2t and multiplication by 1 at the end won't change, -2t. And the exponent of t minus 4 is -2. Now we can find the derivative of this prime of s at t to get the second derivative of s at t. So we write double prime of s at t. So for the first term, we can use chain rule. Now 2 is the coefficient of the term, so it will stay as it is. And for the t minus 4 exponent -1, we can start with the derivative of the outer function, and for that we'll use the power rule. So we'll move the exponent to the front and subtract 1 from the exponent. Times the derivative of the inner function. So the inner function is t minus 4. So the derivative will be 1 minus 0. We can ignore the 0. And then in the second part, so -2 is the coefficient. So it will stay as it is. And now we can use brackets because we'll have to use product rule. So in the second part, there are two functions. So one is t and the other one is t minus 4 exponent -2. So as per the product rule, we'll start with the derivative of the first function. So the derivative of t is 1 times the second term, then plus, so the first function t, and the derivative of the second function can be found using the chain rule. So we'll start with the derivative of the outer function. So we'll move -2 exponent to the front and we'll subtract 1 from it. Times the derivative of the inner function t minus 4, which will just be 1 minus 0. We can ignore the 0. Now we can simplify this expression. So in the first part, so 2 times -1 is -2. And the exponent -1 minus 1 is equal to -2. Multiplication by 1 doesn't change anything. So this is the expression we get for the first part. And now for the second part, -2, then brackets. Now in the parentheses, in the first part, 1 times t minus 4 exponent -2 is just t minus 4 exponent -2, because multiplication by 1 doesn't change anything. And in the second part, so t times -2 will be equal to -2t, and multiplication by 1 at the end won't change anything, so we get -2t, and then t minus 4, and in the exponent, -2 minus 1 is equal to -3. Now we can simplify this further. So double prime of s at t. So in the first term, we can move t minus 4 to the denominator to make the exponent positive. 2 over t minus 4 square. And now we can distribute this -2 inside the brackets. So the first term will become -2, and we can move t minus 4 to the denominator to make the exponent positive. And in the second term, we do -2 times -2t, which will be equal to positive 4t, and we can move t minus 4 to the denominator to make the exponent positive. Now we can simplify this expression by adding the first two fractions because they have the same denominator. So we get the double prime of s at t equals, so -2 minus 2 is equal to -4 over t minus 4 square, and then plus 4t over t minus 4 cube. So this is the expression for the second derivative of s at t. Now we can find the value of the second derivative at t equals -2 by subbing in t as -2 in this equation. So we can continue here. So we get double prime of s at -2 equals -4. Now we can simplify this expression. So the numerator will stay the same in the first fraction, and in the denominator we can do negative 2 minus 4, which is negative 6, and the square of negative 6 is positive 36. And in the second fraction, 4 times negative 2 is negative 8 over, now in the denominator, negative 2 minus 4 is negative 6, and negative 6 to the power 3 is negative 216. Now we can simplify these fractions. So negative 4 over 36 can be reduced to negative 1 over 9. Negative 8 over negative 216 can be reduced to positive 1 over 27. Now we can combine these fractions by finding a common denominator. So the common denominator will be 27. So we'll multiply the first fraction in the numerator and the denominator by 3. So we get negative 3 over 27 plus 1 over 27, and now we can combine these fractions. So negative 3 plus 1 is equal to negative 2. So we get negative 2 over 27. So this should be the final answer for the value of second derivative at t equals negative 2. Now we can answer the second part, whether the curve lies above or below the tangent at this point. Now for the second derivative, we got a negative value. That means the curve concaves down at t equals negative 2. That means the curve lies below tangent at t equals negative 2. So this is how we can conclude our answer for the second part. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.